for the record button to come on. There we go. All right, the question that I've received is a good question because it's got several parts, which is separate questions. Now, while the question itself is not a test question, there's several test questions in the homework question. So if you can do this question as far as the parts, then you're good for 8.1. So here's the question. This is 8.1. 19/5. 8.1 19/5. And here's the question. So I'll give y'all a second to write down the main part, which is at the top. And of course, we're going to draw a picture. So I got to find my, oh no, where is my, there we are.
You got a work email. Priority 1 message
coming
in
on
secure channel.
These people sending emails. I know people have 8 o'clock class.
You got a work email.
I think, yeah, that's, I'm sorry, somebody, I got a meeting Friday and they changed it. Sorry about that. Okay, so we're going to take our handy dandy what just happened there? That's not supposed to happen. There we go. And there is our handy dandy curve. I bet some of y'all are still drawing them, aren't you? No comment. I'm going to be quiet. And it says that we have a mean of 291. And a standard deviation of 23. Of course, they don't make it easy. So, and I'm not going to ask y'all to tell me what the standard deviation is because y'all won't talk to me. So I might as well just do it myself. So clear, second quit, clear, 291 plus, let me look it up again because I won't ask y'all, 23 plus 23. So that's going to be 314 plus 23, 337, and plus 360. And 291 minus 23, 268 minus 23, 245, and minus 23, 222. Okay, the first question said, what is the probability that a randomly selected pregnancy lasts less than 282 days? Well, that's a Chapter 7 question. They haven't done anything new there. So 282, less than 282. So I'm going to take my handy dandy blue marker or red marker, 282. Well, 282 is going to fall in here somewhere. So let's find the middle. Well, half of 23 is 11. So 11 to 268 is 279. So 279 is in the middle. And we want 282. Well, half of 11 is 5. So 5 plus 279 is 284. So that's 284 right there. So 282 would be just about in the middle. And my son borrowed my straight edge. Didn't bring it back. So there's 282 or whatever, 282. So we're going to call that 282. And they say, what is the probability that it will last less than 282? So that would be this area right here. Now, by the empirical rule, let's see, half of this would be, half of that be 17. And then a little bit more than 17, I'm going to say 20. So I'm going to say this is 20. And this is 16. So I'm going to say by the empirical rule, we're talking 36%. And that's by the empirical rule. So let's take, you got an older calculator. We're going to change that 282 to a z-score. Minus 291 divided by 23. And I'll do that because I'm not going to get any help from y'all, so I'll do it. So 282 minus 291 equals 23. I'm sorry. Negative 9 divided by, horse pucky. Negative 9 divided by 23. Negative 0.39. So this new z-score for 282 is negative 0.39. Now, since you are dealing with this side, this is negative infinity, which is negative 9999. So if you got an old calculator, it's going to be negative 9999 to negative 0.39. So let's do a calculator. So second, bars, normal CDF, and lower is negative 9999, and upper is negative 0.39. And if you got an older calculator, you can't change 0 and 1, or it's not even there. And hit paste and paste. I said it was going to be 36%, and it comes out to be 35%. So the empirical rule helped us out there and told us that Your area is around 36%. So our actual answer is 0.3483. 0.3483. Now, if you got a newer calculator, your newer calculator is probably going to be a little bit more accurate because you're using all the numbers and you're not doing any rounding. So let's do it by the new calculator. Second, bars, normal CDF, and I'm going to type in -9999 to 279, I'm sorry, 282, 291, and 23. And see, it calculates all those numbers and it doesn't round any of the decimals. So it's going to be a little bit more accurate. 0.3478. So it's a little bit more accurate. 0.3478. And luckily, the this is old calculator. This is new calculator. And luckily, your answers will be adjusted, and I'll show you how. They usually put a tolerance in there for the calculators. So when you go to your, I can't type in, but it says round, Miss Hicks did 0.3478, so she has a newer calculator. And I assume she got it right because I can't check the answer there. I guess since it doesn't have a red thing there, she got it right. So, but I'm assuming you can put in 0.3483 and you should get it correct. Okay, so if 100 people were picked, we would expect 35 pregnancies to last, okay, less than 282 days. That's the conclusion of this. Now, that is chapter 7. So, as I told you the other day when we were starting chapter 8, you're moving from chapter 7 to chapter 8. They put a chapter 7 question in here just to kind of refresh you on what we did in chapter 7. Now, this is a chapter 8 question. B is a chapter 8 question. So I'm going to draw another picture while you write down B. Sure is nice having these copies. For the one person out there that did it, y'all probably like them too. All right, so we've got, again, everything 291, yeah, 291 and 23, everything's the same. So 291, and that's going to be 314, 337, and 360. And then 268, 245, and 222. Now, this question says, what if, or suppose a random sample of 18 pregnancies is obtained? So N is equal to 18. And they're going to ask down here, this is one question really. What is the probability that a randomly selected sample of 18 pregnancies has a mean gestation period of 282 days or less? So we're still dealing with 282 days or less. But this time, it's not with the old group that we got up here. It's with a new group of 18 women. Okay? So this is a new group. And they say, well, we got this information. What if we take this information and use 18 more people? what would the probability be with those 18 women pregnancies and their gestation period be less than 282 days? So that's what we're going to find out. So we've got this. So this is a chapter 8 question. And the difference in the first question we did and this question is that they are giving us these two things right here. And I'm going to put out here new people. In other words, they went out and got 18 new people, whether it be women, men, Martians, or whatever. I don't care what they are. They're new pertaining to the old research that we did right here. Okay, this was mean equal to 291 and a standard deviation equal to 23. And this is chapter 7. And then they said, well, I'll tell you what, we got this information. Go out and find 18 more people. And tell me what happens when you get 18 more people. What is their probability of being 282 days or less? So 282 will be in the same place, but you can't use the empirical rule now because these are new people. So we're going to just mark out the empirical rule because it don't count here because you're dealing with new people. And the scale of the 282 is going to be different also because I'm going to do that here in just a minute. All right, so first of all, we got to our objective with 8.1 objective. In other words, your goal is to find the new standard deviation, which is called standard deviation x bar. And that's equal to your old standard deviation divided by the square root of n. So that's going to be here. The new standard deviation x bar is equal to 23 divided by the square root of 18. So I'm going to go over to my handy dandy calculator and I'm going to do 23 divided by parentheses 18 raised to the 0.5 power, close parentheses. And if you use 1/2 or you use the square root symbol, you're going to get the same answer. So my new standard deviation is, I'm going to write it in another color. Let's write it in pink. 5.42. Well, I'm going to go ahead and do 291 plus 5.42. So my new, let me use a green, and I'm going to put 291 right here. And my first one's going to be 296 plus 5.42 plus 5.42, 301 plus 5.42, 307. And then 291 minus 5.42, 285 or 286 minus 5.42, 280 and minus 5.42, 275. Now, X bar is equal to 5.42. So now you have a new graph. Now you have a spread of 5.42 instead of 23. And now they're saying, what's less than 282? Well, your 282 now has moved. Now your 282 is right about here. Because these are old. And now your percentage is going to be less than before. Now that you've converted your scores, to the new, you can use the empirical rule. In this case, it's going to be around 2.5%, a little bit more than 2.5% because it does go above the 2.5 right there. So you're talking maybe 2.6%, maybe. No, I probably wouldn't even say it's more than that. So let's see what the answer is. Now I've got to change 282 into a new z-score. So that's going to be 282 minus 291 divided by 5.42. And that green is shot, so I'm going to put that in the wastebasket markers. So I'm going to take my handy dandy calculator. 282 minus 291 divided by 5.42. And now my z-score is negative 1.66. Negative 1.66. So now if you've got an old calculator, you're going to go from negative infinity to negative 1.66. So let's do a new an old calculator. So second, vars, normal, CDF, negative 9999 to negative 1.66. And you can't change this with the old calculator, but there. And I said it was going to be around 2.6 or let's see, 2.6 would be 1.0260. See, it's around 4. 1, 2. It's around 4.84. I thought it would be less than that, more than that. Oh well. Okay, so the answer is 0.0485. 0.0485. Now let's check it with a newer calculator and go second, vars, normal CDF, negative 9999 to 282. Standard mean 291. And now the standard deviation is 5.42. And it should be around the same answer. In fact, it's very close. 0.0485 and 0.0484. So, and this is the new calculator, and this is the older calculator. And that is the area there. Oh, I see why I'm off. 282 is not going to be right there. This is 286. Okay, that's 283 right here. So 282 is really going to be around there because that's 283. So I'm sorry, I didn't draw it right. There it is. I guess I just wasn't paying attention. 280 to 286 is 3. Half of 3, I mean half of 6 is 3, so that would be 283 right there. I was looking at 283 being right about there, so I drew it wrong. So that's why my empirical rule, I said 2.6%. I had it drawn wrong. But we don't need a picture. We don't need a picture. If you're still trying to do this without a picture, more power to you. Any questions so far? You're not going to ask it anyway. Next, a teacher can only take so much silence, and it gets to get on the teacher's nerves after a while. So there's the answer there. And our probability we come up with, now since they got 5.4212, since they did 12, their answer may be a little bit different than ours. So I say, it says round to 4 decimal places. I got 0.04. I'm going to use the new calculator, 0.0484. Now, it may be wrong because they're using 5.4212 and we only used 5.42. So, okay, it's still good because there's a tolerance in there. I wish I could show you, but there is a tolerance in these answers. So what, that'd be 5 people. 5 would be less than, where's less than? Or less. 5 samples. Okay, now you do this one. What is the probability that a randomly selected sample of 46 pregnancies has a mean gestation period of 282 or less? So now they're asking for 46 people. So go ahead and try that one. I'll be drawing my new picture. And this is the 3rd question that we've done. So this is 3 test questions. And yes, I could put a chapter 7 problem on this test. Easy. So you make sure you read the question. $291, $314, $337, $360, $268, $245, and $222. One of my students in the 120-29 class told me yesterday that they have a friend that is in another 120 class, and like half the class is like dropped. And I'm like, Why? And that's, some teachers make this stuff difficult. And I'm not saying I'm not making it difficult. I know I may be making it difficult for some of y'all. I don't know. But I know I don't have half the class gone. And nobody says a word. Y'all have any friends that are in other Math 120 classes? And nothing. Y'all starting to get on my nerves. So,
I think my friend Brooke
what'd you
Cameron
say?
is in. I think my friend Brooke Cameron is in one of your classes.
Yeah, she's in my. I can't remember. Is she in the 120? I can't remember.
I'm not sure. I just saw that she had one of your classes.
She ain't complaining too much, is she?
No, she said it was pretty funny.
Well, she must be in one of the classes that talk to me.
She said she was the only one in there that talks to you sometimes.
Sometimes, yeah. I think she's in the 120. I'm not sure. All right, so n is equal to 46, and they still want the probability of the mean being less than 282. So I'm showing you my picture now. If I get the cursor back into this. See, I'm working with 3 monitors here. I got 2 TV screens and the monitor on the laptop, and my mouse sometimes gets lost. So y'all have to forgive me. So here is the picture, and there is the information that's given, and this is the old 291, 314, blah, blah, blah. Now we know these are going to be no good after we find a new standard deviation. So I'm going to go ahead and find my new standard deviation, and I'll do this one in pink this time. So our new standard deviation is going to be equal to our old standard deviation of what? 23 divided by the square root of 46. So I will take my handy dandy calculator, and that focus looks awful. Is that a little bit better? Yes, Hubert, that's a little bit better. Thank you, class.
I said that's good.
Oh, okay. Thank you, Miss Yates. I appreciate it. You awake, Miss Yates?
Yes, ma'am. I mean, yes, sir.
Yeah, you sound like it. Okay. All right. So I'm going to take my handy dandy calculator, and I'm going to hit 23 divided by parentheses 46 raised to the 0.5 power and close parentheses. And I'm going to take it to 4 digits because they took the last standard deviation to 4 digits. 3.3912. 3.3912. That is our new standard deviation. I'm sorry, yeah. Our new standard deviation, I'm going to say 3.4. Okay, for my graph, for my picture, I'm going to say 3.4. And I'm going to add that right quick. So 291 plus 3.4. That's 294 or 295. So I'm going to mark that out and put 295 plus 3.4. 298 plus 3.4, 301. And now 291 minus 3.4, 288 minus 3.4, 288, that'd be 284 minus 3.4, 281. Now I have a new graph, and now I'm going to graph less than 282. Well, 281, 284, that's 3. Half of 3 is 1.5. So 282.5 is right there. So I'm going to draw a line right about there. Half of 2.35, I'm going to say half of 2 is 1. So I'm going to say 1.15% or 0.0115, somewhere around there. That's by the empirical rule. And if I drew it correctly, I think I drew it correctly this time, because 282 is going to be right about there. So now I'm going to change my 282 minus 291 over 3.3912, 3.3912. So let's do that. 282, and that's negative 9, minus 291 divided by 3.3912. Your new z-score is negative 2.65. So if you're using an old calculator, your new z-score for 282 is negative 2.65. So now if you have a new calculator, negative 9999 to 282. If you have an old calculator, it's going to be negative 9999 to negative 2.65. So let's check it with the old calculator first. Second vars, normal CDF, negative 9999 to negative 2.65 to 0 and 1, because you can't change that on an old calculator. And enter. They got less than I did. I said 0.0115. They got 0.0040. So old calculator, 0.0040. Let's see what the new calculator will do. Second vars, normal CDF, negative 9999 to 282, right? 282. Oops. 282 with a mu of 291 and a standard deviation of 3.3912. 3.3912. Point 0040. A new calculator gave me 0.0040. And that should be your answer. So this area right there is 0.0040, so not even 1%. I said it was going to be around 1%, and of course they got a more accurate answer than the empirical rule. Now you've got 3 good test questions right there. So let's look at the question. The probability is 0.0040. And that means 0 people, or is less, right there. 0 samples. What might you conclude that a random sample of 46 pregnancies resulted in a mean gestation period of 282 or less? This result would be very unlikely. This result would be unusual, so the sample likely came from a population whose mean gestation period is less than 291 days, because it moves it over, I would say. Oh my gosh. The probability that a random sample size of 15 would have a gestation period within 9 days. Okay, so first of all, n is equal to 15. Got to draw a picture. $291, $314, $337, $360, $268, $245, and $222. And they say n is equal to 15. And they want to know the gestation period within what? Within 9 days of the mean. Well, 9 days, let's see, this is 23. So 9 days would be, gosh, half of 23 is 10, 11. So there, so it'd be right about here and right about here. So but we have a, we got to figure our new, I'm sorry. We got to figure our new standard deviation. I'm sorry. So our new standard deviation, we'll do it in orange this time. Our new standard deviation is going to be equal to 23 divided by the square root of 15. So 23 divided by parentheses 15 raised to the 0.5 power, close parentheses. Our new 5.9386. 5.9386. I'm going to use 6 for my curve. So I'm going to go down here and I'm going to take out, so that's going to be 297. That's going to be 306, 305, and 311. And this is going to be 291 minus 6 is 285. 285 is 279. And 279 minus 6 is 273. Of course, y'all can check my math. Now, 291 to 297 is 6. Half of 6 is 3. Okay, so that's going to be, they want to know how many within, oh gosh, 9 days. I can't remember the question, and y'all not going to tell me, so I'll just look for one myself. Within 9 days. So we know this is 6 days. So 9 days would be about half here and half here. Now, by the empirical rule, 68, and what's half of 14? 7 and 7, 68 and 14. 68 plus 14, 6, 7, 80. 80% or 0.8000. And that's by the empirical rule. So let's see what they get. Now we got to change those to z-scores. So, and I know it's getting on close to time. So within, so what is 291 minus 9 days? That'd be 282. And what's 291 plus 9 days? 300. So you got to use your new standard deviation. And I don't know why. Here we go. There we go. $291. Let me check my calculator. 291 minus 9 days. And 291 plus 9 days. So 282 to 300. Now I'm going to use the new calculator because we're running out of time. So second, bars, normal CDF. I'm going to go from 282 to 300, 291, and my new standard deviation is 5.9386. 5.9386. And I got around 80% by the empirical rule. 0.8704, so I'm a little bit off, but 0.8074. I'm sorry, 8704. So write that down. 0.8704. 0.8704 is your answer within 9 days. 9 days here and 9 days here. %, 0.8704. 0.8704. And that means that 87 babies, 87 pregnancies, but they're not going to ask that. Those are about 4 good test questions. Let me look and make sure. Yeah. There's the chapter 7 question. There's the chapter 7 question, which I could put that on test. I don't know. Have I not set the resolution on this thing? No, I sure haven't. That's why I'm running out of room. There. Okay, there's the chapter 7 question. That's the first question. Then they changed it to 46. Then they changed it to 18. And then they changed it to 15. So those are 4 good test questions. If you can do those 4 test questions, you're good for 8.1. And turn that off and turn the recording off. And let me